This is Dr. Sreekanth, Professor, Department of Data Science in Institute of Aeronautical Engineering. In last session, we are explained about the logical connectives. So all the logical connectives were discussed. Now we are going to discuss about the truth tables by using those logical connectives. The first truth table for the expression if P then Q then negation R. So for that we are going to construct a truth table. So here we are going to denote first there are 3 prepositions will be there. So we are going to get 2 power 3, that is 8 combinations we are going to get. So for that first P prepositions I am taking true values, or next remaining 4 are false. Like that the Q preposition is 2 positive, 2 true, 2 false, like that alternatively, and R is a true false alternatively we are going to get. Now whatever the expression will be there, for that if you are going to construct a truth table, so first of all what is the value of this we have to calculate, and after that we have to calculate this. Then we are going to take the compound preposition and then we are going to identify what is the truth value of that. So first let us take a negation of Q, negation of R. So whatever the R truth values will be there, then we are going to take it as opposite. So whenever true will be there, then that will be false. Whenever false will be there, then that will be true. Now after that, if P then Q, we calculated this. So this is true whenever this is false, whenever Q is false, remaining all the cases, it is true. So observe this, first one is if P then Q both are true, so it is true. Then here both are true, it is true. One is false, this is false, and another one is false, this is false. Next remaining is true, this is true, and both false, then also it will be true. So P to Q we calculated. After that the given compound preposition. So then we are taking like this. So here true false, it will become false, true true, it will become true, then false false, it will become false true, and next false true, it will become true, like this. True false, it will become false, like that we have to calculate. True true, it will become true, true false, it will become false, and true true, it will become true. So like that we are going to calculate what is the truth table for the expression if P then Q then negation of R. So now let us discuss the other problem. So here this is the A is like this and B is another one. So first concentrate A as, see here which is of the form, let us say I am saying that this is X and this is Y. So it is in the form of X biconditional Y. X biconditional Y. Why I am taking X as 1 and Y as 2, so then it will become 1 biconditional 2, Y 1 biconditional 2. So which is equivalently written as, 1 if 1 then 2 and if 2 then 1, This is we are going to calculate what is the value of this, So in that way we just calculate. So the biconditional we are going to take it as like this. So for that reason, this is we are taking it as, it's not 1 I am just simply taking, and next another one is 2. So just I am taking this as 1 and this as 2. Let us take first one is the 1 I am going to calculate, that is if P then Q calculated. Then after that Q also 2 also calculated. 2 is negation P R Q. Afterwards if 1 then 2, then after that if 2 then 1, then after that I am just taking AND operation between them. So in that way we calculated. See here, if P then Q calculated first, that as considered as 1, then negation P I calculated, or next to Q, negation P R Q, that will be taken as 2. Then once again if 1 then 2, like that is calculated, then I am going to get the finally. So in these 2 we just apply AND operation. So then ultimately all are true. So I'm going to get the final value is true. And the second one, example is also if P and if P then Q, then P. So first if P then Q calculated, after that, and P and if P then Q calculated, then after that, then I'm taking the final result as like this. So if P and Q, that means in this order I'm finding, this is false to true, it will become true, false to true, it will become true, and false, false, it will become true, 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 it will become true. So in that way, we calculated the final truth to values. Next, another expression. So truth table for the expression P biconditional Q and R. P biconditional Q and R. So here, first if P then Q and R. Then the second one is if Q and R then P. Then after that we are taking AND operation between them. AND operation between them. So first Q and R. Q and R is true whenever both are true. Whenever both are true, the remaining cases, all cases it is false. All cases it is false. Now P to Q and R. So this, then this one. So what is this? This is true. And the next one is result is if I am taking if P then Q and R, it will become. So we are just if P then Q and R, Q and R. So the first one is true. The second one is false. The third one is just I'm calculating in that order. And after that, we are taking opposite this. So here, first I am taking that straight away. So if P to Q and R is true, then and true to true, it will become true. So the first one is true and true. So it will become true. The next one is true, false. It will become false. Then false and true. So it will become true. So false and true. False and true. This is false and true. And the next one is true to false. It will become false. And the next reverse. So false to true. It will become true. So simultaneously we are going to get false, false. And the next one is true to false. It will become false. And then it is opposite. It is true. So automatically this one will get. So like that we can calculate all these values. So I'm going to get all P biconditional Q and R. See, suppose if I'm taking this one false, false, then it will become true. And reverse if I'm taking, this is also true. So finally I'm going to get the result is true. And here this is also false, false, it will become true. And this is also true, opposite. So then I'm going to get this one. So now next again false, false, it will become false, false, it will become true. Then once again it will become true. So like this we can calculate the compound proportion to the values. Now let us go for the other example in the same way. So first of all we calculate what is P and Q. Then after that we are taking negation. After that I am going to calculate this. So similar manner we are going to calculate. So first one is a conditional. So this, if this and then this, then opposite we are going to take and. So here the first one is whatever P and Q we calculated. Then after that we took negation. Then after that negation P we calculated. After that negation Q we calculated. After that negation P or negation Q. So finally we are taking both conditions are satisfied. So observe these two. Observe these two. So first one is negation true, true. It will become only true. Then opposite. It will become once again true. So the final is true. So next another one is also true, true. It will become true. Opposite also true. So this is true. Then the next one is it is also true. And then it is true. So finally it is true. Next false, false. It will become true. And once again false, false in this way. So once again it will become true. So this is result is true. So like this we are going to get all the truth values of this. So first we are taking in this order. We are taking in this order. After that and we are taking the next reverse order. Next let us consider another example. Let P, Q and R be two proportions which are having specific values are given. That means P truth value is false, Q truth value is false, and R truth value is true. So then what is the compound proportion truth values? So first one, it is given already. So it is a P truth value is false, and then again it will be true. So subsequently false is nothing but false and true. This is equals to false. So the first one is false. So it is not necessary to construct a truth table because it is already given the truth values of P, Q, R. So based on that, we just simply calculated. So it is false, then and Q and R. Q and R is nothing but false and true. So which is implies false, then false. So which is equals to true. The second one is true. And the third one is if you are going to construct. So that is third one is first one is false. Then the third one is this is and R is what is R is true and Q is false. So this is once again false and false. So this is equals to false. So that is this. Next another one is this is false. Then Q is false. Then negation R, negation false. It will be true. So then it will become false to true. Then result will be true. Result will be true. So in this order, that means whenever a particular truth values are given for the given proportions, then you have to, based on that, we have to find out what is the truth value for the compound proportion. In this order, we are going to calculate. Then this is some simple examples based on the truth value, truth tables, how we are going to construct the truth tables, and based on these compound proportions. Earlier we discussed all the things. Now, the another concept is a well-formed formula. What is a well-formed formula? When we say that a formula is well-formed, so for that, there are certain rules will be there. So there are 4 rules are there. So based on these 4 rules, we can say that the given compound proportion is a well-formed formula or not. See here, the first one is a statement variable standing alone is a well-formed formula. That means the proportion, let us say I am considering P is a proportion, Q is a proportion, R is a proportion, and so on. The proportions which we are going to represent with the capital letters or small letters, whatever it is, and whenever if you are going to denote a statement or a proportion is standing alone is a well-formed formula. That is P is a well-formed formula, Q is a well-formed formula, R is a well-formed formula. So any statement variable stand alone is a well-formed formula. Then the next one, any well-formed formula if you are going to consider, that means a statement variable if I am taking, then the negation of the statement variable is also a well-formed formula. So for that, if I took negation P is a well-formed formula. If I took negation Q is a well-formed formula. If I took negation R is a well-formed formula, like that. If any statement variable, if we are going to take negation, then it is also a well-formed formula. Now the third one is, if 2 well-formed formulas will be there, then we are going to connect, we are going to combine them by using any type of logical connectives, then it is also a well-formed formula. It is also a well-formed formula. While if you are going to consider the logical connectives, see that the parentheses are properly mentioned or not. See here, this is a closing parenthesis and this is the opening parenthesis and closing parenthesis. So, if while combining 2 proportions by using any logical connectives, we have to concentrate on the parenthesis. So, parenthesis, if properly mentioned, then it is also known as a well-formed formula. Then if you are applying these three in any number of ways, we are going to get a resulting compound proportion that is also a well-formed formula. There is also a well-formed formula. So any formula, if satisfies the four conditions, then that is also known as a well-formed formula. That is in well-formed formula. So what are some of the examples? It is mentioned here. Let us first concentrate. This is not A. This is AND. P and Q. See, already we said that P and Q is a well-formed formula because P is well-formed formula, Q is well-formed formula. So P and Q is well-formed formula. So whenever P and Q is a well-formed formula, then the negation of well-formed formula is again a well-formed formula. And next another one is P or Q. P or Q is P and Q both are well-formed formulas. Then we are combining them. Then it is also a well-formed formula. See, the parentheses are opening parenthesis and closing parenthesis are same. Then we can say that it is these are all in well-formed formulas. Observe that thing. Now let us concentrate. Below, some of the expressions are mentioned. And these are not well-formed formulas. Why these are not well-formed formulas? See here, this is not a well-formed formula we are saying. Why it is not a well-formed formula? Because there is no parenthesis. Parentheses are not properly mentioned. So, while I am taking this is not well-formed formula, but at the same time, either this one or this one, both are well-formed formulas. Both are well-formed formulas. See here, unnecessary logical connectives are also not mentioned. So here, let us take the second one. See here, this AND, logical connective AND is mentioned here, but there is no meaning for that. There is no meaning for that. So we can say that it is not a well-formed formula because this is not a well-formed formula. Of course, this is a well-formed formula, but this is not a well-formed formula. So the result is not well-formed formula. So if we remove this and we are going to add one more braces, so then it will become a well-formed formula. So I am taking this thing as like this. So if P, then Q, then Q, I am taking like this. If I am mentioning like this, then it is a well-formed formula. Now here, observe the third one. See, one brace will be there started and there is no ending brace. So it is not well-formed formula. But if you are going to take like this, it is a well-formed formula. So like that, see here, this is, observe this. This is also not well-formed formula because the opening braces are only one, here closing braces are two. So if I am going to add one more, it is a well-formed formula. It is a well-formed formula. See, so that means while explaining the compound proportion which is in well-formed formula, see that the atomic variable or see that statement, standing alone statement is also a well-formed formula. Then only the result will be the informed formula. So these are the four properties which are satisfying any proportion, any compound proportion. Then we can say that that is in well-formed formula. Otherwise, it is not in well-formed formulas. Okay. Now let us discuss. We know how to construct a truth table. After constructing the truth table, then we have to verify whether the compound proportion is a true or false or mixed with both. So now, such a situation, in all the combinations of truth values of the given proportions, the resulting compound proportion, which is true, then we can say that the compound proportion is a tautology. So here, P is one proportion, negation P is another proportion. If I am taking R, disjunction operation between them, for all the possible combinations, we are going to get the truth value of P or negation P is true. So I am saying that it is a true, it is a tautology. It is a tautology. And in the same way, for all the combinations, if we are going to get a false, then it is known as the compound proportion, compound statement, or we can call it as a compound proportion, which is a contradiction. See, the tautology we are going to represent with the symbol T naught, whereas the contradiction we are going to represent with the symbol F naught or T naught. Or sometimes you can make it as showing the difference between the truth values and the tautology. For that reason, just we took T naught and we took F naught as the tautology and the contradiction. Suppose if we are going to get both results, that means for some combinations we are going to get the true, for some combinations we are going to get false, then the compound proportion is known as a contingency. Let us go for the other one. See here, the compound proportion. This is the compound proportion. We are going to verify whether it is a tautology or contradiction or contingency. So for that, so whenever P, Q are true, then this will become true. Whenever P is true and this is false, then this will become false. So they observe the combinations. So false, true, it will become false. Then the combinations, if I am taking false, false, then the result is false. So here in this column, for this given proportion, we are going to get, then here some are true and some are false. In such a situation, the compound proportion is known as a contingency. A contingency is a compound proportion which is neither a tautology nor a contradiction. Both. So it is not a tautology, it is not a contradiction. In another way, we can say that a contingency is like that. Now we are going to verify. Whatever the given, some compound proportions are given, and we are going to verify whether it is a tautology or contradiction. So here, observe this. I am just representing two compound proportions in one table. So this is this one, and next another one is this. So mentioned in the same table, and observe if P then P are Q values. So P are Q, observe these are all truths. And here it will be false because both are false. P or Q is false whenever both are false. Otherwise, in all the cases, it will become true. So now observe. If P then P or Q. True, it will become true. True, it will become true. False, true, it will become true. False, it will become true. So all combinations are true. So we said that if P then P or Q is a tautology. And the rest of them, and here negation P, the another one is, we are going to calculate P and negation P. So for that negation P we calculated, negation P and Q calculated. Then we are going to consider P and negation P and Q we calculated. Then the whole thing will become, see, P and true and false. Then this will become false. True and false, it will become false. False and true, it will become false. False, it will become false. So all are false. So I can say that this is a contradiction, whereas this is a tautology. So now let us concentrate the another one. So prove that for any proportion P and Q, the compound proportion is a tautology. Once again, we are going to prove this. The compound proportion is a tautology. So for that, once again the same consideration. First of all, we are going to calculate what is this, and negation P we calculated already. So negation Q will be there. So first I am going to calculate what is this. Afterwards I have calculated what is this. Or else in the other way also we can calculate. Then we are just calculating what is the compound proportion truth value. So now in all the possible cases, we are going to get all are true. See here, the first one is the compound proportion. This is true, this is false, and this is false. And the negation P, if I am just applying this. So for this, true, it will become true. And false, true, it will become true. Next, false, it will become true. Then false, it will become true. So this is the previous methods and how to construct a truth table. Same, by using that we constructed. So finally, the resulting, we are getting all our truth values. So we can say that this is a tautology. So let us go for the other example. So now, once again, find the feasible situation, possible situations in which the following are contradictions. So this, we are going to say that this is a contradiction. For that, what are the truth values that we are going to assume for the statements P, Q, R, S, T? Because it is having 5 prepositions, 5 statements it is having. If I am going to construct a truth table, then what are the combinations will be? 2 power 5 combinations will be. So 2 power 5 combinations are, so there are, it is very hectic task. 4 and 4, 16. 4 into 4 into 2. So 32 combinations we are going to get. So 32 combinations, with that 32 combinations constructing a truth table is very difficult. So for that, it's simply asking. And we are not going to verify, we are just simply saying that what possible situations. So the compound proportion is the contradiction. So for that we are going to calculate. So for that, see the right hand side, when the conditional will be false, whatever this is true, then this will be false, then this is false I am waiting. Or another one is there is no other one. So if I am taking false, it will become true. So the left hand side, that means that this value should be true, and this value should be false. So in such a way that we are going to choose the truth values of P, Q, R, S, T. So the right hand side, S and S or T should be false. For that reason, when S or T is false, whenever S is false and as well as T is false. So for that reason, we consider S, T both are false. And now another one is, we have to get true. So for that, when it will become true? So whenever this only situation is all are true, then only it is true. Otherwise there is no possibility. Here true and false, then this will become false. So there is only one possibility. So for that, this should be true. Then apply true and true and true. So this is true and true. It will become true. Then once again true and true. It will become, this is true and true. So this is false or false. It will become false. So finally I am going to get the result as false. So in that way, we are just taking the truth values of the given proportion in such a way how we are going to get a contradiction. Next, another topic, logical equivalence. When we say that two compound proportions are logically equivalent, one is constructing a truth table and verifying those two compound proportions will have the identical truth values. That means whatever the compound proportion is considering in one column, the other compound proportion is considering in the other column. If both are same, then we can say that this is logically equivalent. One method. See here, we are just saying if P then Q and negation P are Q. We have to verify whether these two compound proportions are logically equivalent or not. So for that, construct a truth table for this. See, if P then Q truth values and negation P or Q truth values are both same. So we can say that these two are logically equivalent. Logically equivalent. And which is denoted by this symbol. Which is denoted by this symbol. See, constructing a truth table, if it is having a compound proportion is having n statements, then it will be very tedious task. So for that, one method is constructing a truth table if the number of statements are less. So otherwise, we go for the other method. So first one is logical equivalence. We are going to show that by using a truth table. After that, we are going to use a derivative method, or else we are going to use some formulas. Now see that for any proportions P, Q and R, prove that this is logically equivalent to this. So here we have only 3 proportions, so 8 possible combinations will be there. So we are just taking the truth table and we are going to verify. Whether both are logically equivalent or not. So for that, observe for this. This is the truth value. See, this is the first compound proportion. And this is the left hand side and this is the right hand side. Another way we are calling it as. So left hand side and the right hand side. Now just to verify the left hand side, all whatever the values we are getting. True. Then another one is false. And another one is false. And another one is false. And another one is true. 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 See, observe this. For all the combinations of the truth values of P, Q, R, so both columns are identical. So we can say that they are logically equivalent. And so logically equivalent means we can replace that. Okay, identical truth values of this. So in that way we can say that logical equivalence. Now see, this is while constructing the truth table, no problem. Whenever the number of statements are less, then it is going to be used. Whenever the number of statements will be more, then how we are going to verify the logical equivalence of two compound proportions? It is not possible to construct a truth table. So very huge truth tables. So in such a case, we are going to use the formulas. You are going to use the laws. Those laws are known as the laws of logic. So in order to, instead of using logical equivalence by taking the truth values, we are going to use the formulas. Now, see here there are some formulas will be given. Logical equivalence, or first one is identity law. This is identity law can be represented in this way. Next, domination laws. Domination laws are like this. PRT is equals to T. P and false. P is any proportion. P is any proportion. And false. It will become false. Idempotent laws. So P or P is equals to P. P and P is equals to P. Then double negation. If you are going to take double negation, negation P is equals to the given proportion P. And commutative laws. Commutative laws. That means either we can take it as a P or Q or Q or P, or P and Q or Q and P. Both will give same value. Next, associative laws. Associative laws. In the same way, if P, Q, R are any three proportions, then while we are applying R operation or AND operation between them in any order, we can consider. So P, R, Q, or R. So I'm just shifting the parenthesis. First 2 to 2, last 2 to 2. So like that, first 2 variables to last 2 variables. So like that, we can change. So this is the associative law. And distributive laws. This is one of the important concepts. So distributive laws. P, R, Q and R is equals to this. Q, P and Q, R is equals to this. And De Morgan's laws. This is also a very important one. De Morgan's law. Negation of P and Q is identically equivalent to negation P or negation Q. Next, absorption law. Absorption law means whenever P, R, P and Q will be there, the entire thing is equivalent to P. That means the entire thing is replaced with the P. Similarly, P and P or Q is also P. So these are the absorption laws. And negation laws. Negation laws are this. P, R, negation P is true. P and negation P is true. Already we proved this by constructing two tables. Some of them are, not all. Now let us consider by using laws of logic without constructing a truth table. We are going to prove the given compound proportion. We are going to reduce the given compound proportion to another compound proportion. So whenever I'm applying these laws of logic and we are going to reduce the given to another form, then we can say that both reduced form and the given forms are equivalent to each other. So for that. So now equivalency. Now the first taking that. So first I am taking this. So this is negation. Just what is the negation of P or Q? So we are going to apply. See what is this? This is the, see here it is De Morgan's law. What is that? Negation of P and Q. Negation of P and Q. Or negation of P or Q. Just we are going to apply this. See here, negation of P or Q, sending negation inside. That is double negation P and R and double negation Q. So this is R will become and. So just to try to concentrate for this only. So for that, just taking negation inside, double negation P and then this will become double negation of Q. So negation of negation, which is equivalent to P and negation Q. So that is given here. We apply the De Morgan's law on this and we are going to reduce that. So now let us concentrate. This is, let us observe this. This is P. This is, see what is this? P and. I'm going to rewrite this as P and PRQ. P and PRQ. P and PRQ is, okay. So, P, sorry, this is not absorption. So P and, see here, no this. Now absorption law, we are going to apply this. P and PRQ. P and PRQ. So by using commutative law, if you are going to apply, this can be written as P and PRQ, P and PRQ, then P and PRQ will become P. So I am not going to apply any operations on this. See, observe this. See, here it is. This is whole thing I am taking P and Q and R. So this is of this form. PRQ is taken this as one component. This is another one. So apply associative law. So what I am going to get? P and Q and R. So now for this, we are going to apply absorption law. So this will become P. The whole thing will become P. And of course, I am not going to change this. This is negation of Q. Now the second one, logical equivalence of this. We have to verify the whole thing is equals to P. Once again, see directly, this is by straight away we are going to apply the absorption law. So this is equivalent to P. PRP, which is equal to P. So without using, then I can say that this and this both are equivalent, and this and this both are equivalent. Now let us go for the other problems. Show that is logically equivalent to this. Now, first one, we are going to consider the given proportion is this, compound proportion. Then just apply taking negation inside. So apply De Morgan's law. Just we apply negation, sending negation inside. So this is reduced to this. And Q I am not disturbing. Q will be the same as it is. Okay. After that, apply distributive property. This is of the form. After this, what I am going to get? This is PRQ. Then this. Then apply distributive property. This is the distributive property. Then applying the distributive property. So we are going to reduce this is expression as like this. Then after that, and another inverse law applying. Here inverse law is this. So we are going to get it is false. Next, apply identity law. This is a PR false. It will become P. So the P in the place of P we have this. So take negation outside. Then negation. I am just rearranging this. Negation P and Q. So it is equivalent to this. Next, another one is show that is logically. So this is same as it is. Okay. Now let us go for the next one. Show that this one is logically equivalent to this. So observe this. So we applied only on this and this, reduced to this. So in the first step, only the second compound proportion is reduced to this one. So here it is a distributive property we applied, and the result of this distributive property is this. So I can replace this as this. Then afterwards, I apply operation on this, performing operation, and I am not going to disturb the whole thing. I am not going to disturb this entire thing. And the remaining component I am changing. So this is. So negation P and negation Q and negation R. So this is AND operation will be there. So apply associative law. So parentheses are shifted. So I am going to get like this. See here. Negation P. Okay. Now in the next step, here it will be, I am adding these two. This one and this one. Observe this. R, I am not just taking R as the factor as out. That means applying distributive property. So this is whole thing and R. That is what is this? This and R, this and R. this and R, this will be there here, this and R, this will be here. So I am going to rewrite this by using distributive property like this. So afterwards, I took negation outside. So negation of PRQ, this will become negation of PRQ. And this will be commutative law applying. QRP is equals to PRQ. Just I am going to get like this. So which is of the form PR negation P. PR negation P, which is equals to true. Which is true. And R will be there. So finally we are going to get R. Finally we are going to get R. So the given compound preposition is logically equivalent to that. Next, another example is show that the given compound preposition is a tautology. Tautology means we have to prove that it is a T naught. That is a true. That is a true. So for that we have to prove like this. Now let us take the first one and construct the same as it is taking. And now let us take the two components. First two components. And written as like this. Negation P and negation Q are negation P and negation R by using distributive law. If I am applying distributive law here, I am going to get this. I am going to get this. So this is reduced to this one. And the next step also I am not going to disturb anything. Now concentrate on the other side. So here P and Q will be same as it is and sending negation inside. Sending negation inside. Double negation P and will become R. Then sending negation of this. Negation of this. Sending negation inside. So finally we are going to get double negation is a P and R. Then negation sending inside. Then this will become like this. Then this will become like this. Now, this is once again. So it is a PR applying distributive property here. Applying distributive property here. So PRQ, observe here. PRQ and PRR. PRR. So the next term we won't disturb and the same as it is will be there. Now once again PRQ. Next, and PRR. See here, PRQ, PRQ, and PRQ. It is, and operation will be there. P and P is P. So these two are replaced with single. PRP, PRQ. Next, the rest of PRR will be there as it is. Will be there as it is. Now we are going to apply the De Morgan's law. Then we are distributive property, distributive property. We are going to rewrite the whole thing as like this. The whole thing as like this. And here we just took negation outside. Negation outside. See, our intention is to reduce the, when we are going to get it is a tautology, we have to reduce this in the form of PR negation P. PR negation P. So the whole thing is P, R, negation of the whole thing will be there. Negation of the whole thing will be there. So it will become true. So then it is a tautology. The given compound preposition is a tautology. So here we are using the rules of logic or laws of logic and we are going to reduce. We are going to reduce to its equivalence form. To its equivalence form. Now let us go for the other example. Prove the following is a logical equivalence without using a truth table. Without using a truth table. So first problem is. So now, so for this, the first one is just this component. Take this one is. This one alone, I am just modifying. Just taking negation outside. Negation outside. Then if I am took negation outside, then it will become PRQ. PRQ. Sorry, this problem is just to have to keep here R. Then this is R. This is R. Then that will become, slight modification will be there. That is negation PR. negation Q and R. So if I took negation, then P and Q and R. So same R will not be disturbed. So that is. Now I am going to take the same thing like this. So now it will become, in the place of this, the whole thing is replaced with this. So replace that. This is the replaced. And next, after that, just apply. I am taking just, we are taking these two as like this. Same. And now observe this. PRQ and apply distributive property. PRQ are negation of this one. Distributive property. And the second term, for the second term we are getting this. PRQ, this is a PRQ are negation of P and Q. P and Q. See here, this is okay. The thing is, only this is wrong. Here we have to replace. Here we have to replace. This is, this one is PRQ. This is, sorry. This is replaced. And this is PRQ. Then this is PRQ. So this is this is a negation of PRQ or negation of PRQ. So then this will become PR negation P. So then this will become true and this will be the same. So finally we are going to get this. Then this is the way that there is a mistake here. So we have to rewrite. It's not a and, it should be or. Now, let us take down the second problem. So, we are going to prove this is the reduced form P and Q. So, next, this is, we are going to consider it as. So, this is if P then Q. If P then Q. So, which is equivalent to negation P or Q. Negation P or Q. So here it is, this is a P and this is Q. So which is negation P or Q. In the place of P we have this. So negation of P or Q. So sending negation inside. So P and Q are, this is the same. Now this I am going to write it as, P and Q are P and Q and R. This is, I am going to rewrite like this. Then which is of the form? Absorption law. By using absorption law, P, R, P and Q is equals to P. So for that reason, by using absorption law, this is equivalent to P and Q. This is equivalent to P and Q. It is based on P, R, P and Q. By using this law, we are going to get, this is the result. So this is the absorption law. By using that, we are going to get the final form. Now these are some of the practice problems. Now the concept, another one is principle of duality. Suppose U is a compound proportion which is containing and R operations, which is containing and R. While we are going to write its dual R, and of course, if you want to write its dual, those are replaced with R and R is replaced with R and. Suppose the given compound proportion is having true, then it will become false. If it is having false, then it will become true. That means whenever, if the given compound proportion is having and R, then it is going to be replaced with or and if it is having true, false, those are replaced with false and true. Whatever we are obtaining, then that is nothing but that compound preposition is nothing but a dual of the original one. Dual of the original one. If U is the given compound preposition, then its dual we are going to represent with the symbol U power D. U power D. Let us say example. For example, U is a compound preposition. So which is having and are true. See, observe here, we are not going to change any negation. Any negation we are not going to change. Only these four operators, only these four we are going to change while constructing a dual. So let us take the dual is representing with U power D, and here see this and is replaced with R is replaced with and, negation is not changed, and true is replaced with false. True is replaced with false. So in this way we are going to get the dual of the given preposition. Now dual of dual is the original compound preposition. Dual of the dual is original compound preposition. For any two prepositions U and V, if they are logically equivalent, then their duals are also logically equivalent. Two compound prepositions are logically equivalent, then their duals are also logically equivalent. So let us, why we are going to use this duality principle? What is the necessity of this duality principle? See some of the concepts, observe this here. Prove this, says this, deduce that, the another one. Observe the first compound preposition and the second compound preposition. First one and second one. You observe this. See, just R is replaced with and is replaced with R. I am going to get the second compound preposition. So this one is, from this I am going to get this. So dual of this is this. So whatever I am getting here result, if I am going to prove the first result, I took dual of this one. Second one is need not be proved. And automatically just we are going to write the dual of its, then we are going to get the result. So for that, the first one is, see, as usual methods by using the rules of logic, laws of logic. So we are going to get, see here, negation P R Q, and see the first one for this, we apply idempotent law. No, not idempotent law. Just we are going to take it as P and P. See, it is not idempotent law. So here it is by applying associative law, then I am going to rewrite. This one is like this. I am going to rewrite, this one is like this. And this once again, P and P will become P and Q. So that is the way that we are going to get this. Applying associative law, and then P and P is equals to P. Apply both laws, then this is reduced to this. So after that, once again the same thing, P, R, P and Q. This is just we are taking, applying distributive property. So first I am going to apply on this. After that I am going to apply on this. First apply distributive property on this, afterwards this. See, this is negation P, and see for negation P, afterwards Q. Then once again, this is of the form. Once again we are going to rewrite this expression as applying associative law. So negation P and Q. See this, I am going to write this. This is, I'm taking like this. So this is nothing but false. And Q. And Q. And here, of course, this is the same way. How I'm going to write this is just we are going to rewrite it as Q, and then it is applying commutative law, then I'm going to write this like this. Once again applying associative law, then I'm going to rewrite like this. Then applying afterwards and Q will become Q. So I'm going to get like this. So this is this. So now F and Q, then I am going to get F naught and apply for this commutative law, then I am going to get P and Q. Then identity law, by using identity law, F naught or P is equals to P. So I am going to get this is P and Q. Once if I am going to get the first result, the second one is the first compound proportion. The second one is its dual. So here we are going to use a dual concept, and straight away we are going to write its dual of that. So which is nothing but the second one. So whatever one result we are going to obtain, if the compound proportion, another compound proportion is nothing but its dual, then automatically, then automatically we are going to write the reduced form dual, then automatically we are going to get the final result. So this is the way that we are going to calculate the dual of a given compound proportions. So today I'm going to wind up this session, and tomorrow we are going to discuss some more topics on this.
Like, share and subscribe. Hit the bell icon for more updates.